Hi, Hope. We're going to do page 229 in math, areas of complex figures. And so basically what this lesson is saying is when you have a shape that does not follow like your standard square, rectangle, triangle, circle that can have a formula for area, we're going to break down the shape into two or three different shapes that we can find the area of and then add them together. So for instance, for this shape, in the example, it says it has 3 inches here and 7 inches here, and the whole bottom is 9 inches, and this side over here is 4 inches. So by breaking it into two separate areas or two separate shapes, if you think of it as like this would be one rectangle that we're finding the area for, and this would be the other area that we're finding, or rectangle that we're finding the area for, and then we're going to add them together. And so when we do that, first we have to find out what are these other sides. So this rectangle, we know the length is 7, the width is 3. And so knowing the area of a rectangle is length times width, this is just going to be 7 times 3, which is 21. Okay, and that is for this rectangle. For this rectangle, the whole base is 9 inches, but we need to find out what is the area or the length of this specific line. So if this one is parallel, which means this is 3 inches, that means that the remainder would be 9 minus 3, which is 6 inches, which means this area of the rectangle would be 6 times 4, and 6 times 4 is 24. And so to find the area of the whole shape, we would add the 21 inches from the first rectangle, the 24 inches from the second rectangle, and 24 plus 21 would be 45 inches squared because it's area. And so this is what we're going to be looking at. Breaking down the complex shape that we have, finding the area of the pieces, and then either adding or subtracting those to find the area that they're looking for. So let's look at the first one. For the first one, we have a circle inside a square. And we're just going to tighten these up a little bit. Okay, so what they want us to find the area of is this space in here. So here and here and here and here. This is what we're finding the area of. So let's look at the information we do have. So far in this, we know that we have the diameter of this shape, and the radius from the center point is 2.5 feet, which means that our diameter, the whole thing, is going to be 5 feet. Now, because the diameter from this side to this side is 5 feet, that means that the sides are also going to be 5 feet. So 5 feet, 5 feet, 5 feet, and 5 feet. All right, so we need to find two different areas here. We need to find the area of the square, and we need to find the area of the circle. And then to find this space left over, we are going to subtract the two. So first we're going to do area of a square. And the formula for area of a square is side squared. If our sides are 5, then we're going to be doing 5 times 5, which is 25 feet squared. So that is the area of our square. Next, we need to find the area of the circle. And so for the area of a circle, we're going to be doing pi times radius squared. So first, our radius squared was 2.5 times 2.5. 5 times 5 is 25. 5 times 2 is 10, plus 2 more is 12. Add in our 0. Erase what we borrowed. 2 times 5 is 10. 2 times 2 is 4, plus 1 more is 5. When we add those together, we get 625, but we need to move the decimal 2 places over, so we get 6.25. So that is our radius squared. We then need to multiply that by pi. So we have 6.25 times 3.14. When we multiply those out, we have 5 times 4 is 20. 4 times 2 is 8, plus 2 more is 10. 4 times 6 is 24, plus 1 more is 25. Add our 0, and then we're multiplying by 1, so we get 5, 2, and 6. Add 2 zeros, and we're going to multiply by 3. 3 times 5 is 15. 3 times 2 is 6, plus 1 more is 7. 3 times 6 is 18. When we add all those together, we get 0, 5, 12, 16, 9, and 1. We need to move our decimal 4 places over. So 1, 2, 3, 4. We can cross out our 0 in the end. And so we get 19.625 feet squared. That is the area of our circle. All right, so we have 2 areas now. We have the area of the total square. We have the area of the total circle. And so the square minus the circle area will give us these little corners that we're looking for. So we're going to be doing 25.000, because there are 3 numbers after the decimal for a second number, minus 19.625. All right, now we're going to have to do a lot of borrowing. So we have 4, this becomes 10 and then 9, 10 and then 9, 10. 10 minus 5 is 5. 9 take away 2 is 7. 9 take away 6 is 3. Bring down our decimal. We can't take 9 away from 4, so we need to borrow. 14 take away 9 is 5, and then 1. So we are left with 5.375 feet squared. And that will be the area of the red, or actually green in your book, the green section inside the square but outside the circle. All right, let's go to B. For B, you have a shape that looks like this. The information we know is that the top line is 12 meters. This side line is 9 meters. This line is 4 meters. And down here is 5 meters. Okay, we can break this shape up into 2 rectangles. So if we break this into 2 rectangles, we know that the length is 9 and the width is 5. So we can find the length and width of this rectangle. So area equals 9 times 5, which equals 45 meters squared. So that is the area of the first rectangle. The second rectangle, now we know the length of the top is 12 meters. And so because this side is 5 meters, that means this side has to be 5 meters. And so in order to find the difference between 12 being the whole length of this side, take away the 5 meters, we get 7 meters. And so finding the area of this rectangle is going to be 7 times 4, which is 28 meters squared. Now to find the area of the whole shape together, we're going to add the area of the first rectangle plus the area of the second rectangle. So 45 plus 28, 8 plus 5 is 13, 4 plus 1 is 5, 6, 7, so we get 73 meters squared. And so that's going to be the area of the entire shape. All right, let's go on to the third one. All right, for C, we have a shape that looks like this with a triangle on the side that forms a right angle. And a right angle here and a right angle here. Okay, so we know we can break this shape into a rectangle and a triangle. Information that we already know is that this top line is 12 yards. The side is 8 yards. The base, this whole base, is 16 yards. Okay? And so if we know that this line is 12 yards, this line needs to be 12 yards. And so in order to figure out what this is, we need to do the 16 yards total, take away the 12 yards of this rectangle, and 16 take away 12 is 4. So this little thing is going to be 4 yards. Now, because this side is 8 yards, that also means that this side is 8 yards. Okay, now with that information, we should be able to do the 2 area problems that we need. First, the area of this rectangle. So we're going to come over here, and we're going to do area equals length times width, so 12 times 8. And 12 times 8 is 96. So that's going to be 96 yards squared. So that's the area of that rectangle. Then we need to come over here and find the area of this triangle. And the area of a triangle equals half of the base times the height. Our base is 4, and our height is 8. So half of 4 is 2. Our height is 8. And 2 times 8 is 16 yards squared. So that's the area of our triangle. So we have the area of a rectangle, area of the triangle. Now we need to add the 2 together in order to find the area of the shape as a whole. So 96 plus 16. 6 plus 6 is 12. 9 plus 2 is 11. So we get 112 yards squared. And that would be the area of the entire shape. By breaking it down into parts that we have formulas for, it makes it easier to be able to calculate. All right, last one. I know this is green, but we're going to do it anyway for the practice. And this one's a little tricky, so it'll be a good challenge. All right, we have a circle. We have a triangle that goes through our circle. Oops. Line here, and a line here. Okay. All right, and we know that the diameter is 10 feet. This is also not just one triangle, but it is 2 congruent isosceles triangles, meaning they form a right angle and 2 of the sides are the same length. Okay, so how are we going to figure this out? First, let's figure out the area of our circle. Okay, so we know the area of a circle is pi times radius squared. If our diameter is 10 feet, that means our radius is 5 feet. So we are doing 5 times 5 equals 25. That gives us our radius squared. Then we're going to do 3.14 times 25. There we go. All right, we're going to multiply these together. 5 times 4 is 20. 5 times 1 is 5, plus 2 more is 7. 5 times 3 is 15. No. We're going to go on to add a 0 and then 2. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. We're going to add these together and we get 0, 15, 8, and 7. We're going to move our decimal 2 places over, get rid of our 0. And so the area of our circle is 78.5 feet squared. Okay, so that's the first equation. We're going to have lunch as soon as I'm done. The next one, we need to find the area of these triangles. Now, they are congruent, which means they are the same size and the same shape. So we actually only need to find the area of one of them, like this one. And then that's going to equal the same as this one. All right. So if our diameter is 10 feet, we know that that means that this equals 5 feet, which also means that this radius equals 5 feet. Okay? So if we're doing our formula, area equals half of the base times the height. Okay? This is going to be our base of the triangle. And so half of base, which is 5, and our height is 5, that means half of 5 is 2.5, and we're doing 2.5 times 5. So 5 times 5 is 25. 5 times 2 is 10, plus 2 more is 12. Move our decimal one place over, and we get 12.5 for the area of one of the triangles. So that means this is 12.5, but that also means that this is 12.5. So we need to add the two together or multiply by 2. Multiply by 2. 2 times 5 is 10. 2 times 2 is 4, plus 1 more is 5. 2 times 1 is 2. Move your decimal one place over, and this is feet squared. All right. So we have the area of the whole circle, which is 78.5 feet squared. We have the area of both triangles put together, which is 25 feet squared. And so we need to subtract the two of those to figure out what the red section area would be. So we have 78.5 take away 25.0. 5 take away 0 is 5. Bring down our decimal. 8 take away 5 is 3. 7 take away 2 is 5. So we get 53.5 feet squared. And that gives us the area of the red section of the circle. Awesome. So basically what this lesson is teaching us today is it's taking shapes that are not your standard shapes that have a specific formula for them. It's breaking them down into shapes that do have specific formulas and then adding or subtracting those together depending on what area you're trying to find. If you're finding two shapes that are next to each other, then you're adding those two areas together. If you're trying to find the area of a space within a polygon or within a circle or shape, then you're subtracting because you're finding the difference of the total area minus the area inside the shape. And so it's all formulas that we've been using. It's just knowing how to break the shape down, the irregular shape, into shapes that are regular, that have regular formulas, in order to then do your computation, add or subtract them together to get the area of the part that they're looking for. All right, we are not going on to problem solving strategies for today. I'm going to give you a break. And tomorrow we're going to go on to angles, which is a little easier than this. But hopefully that helps. If you're still having troubles with it, just save it for tomorrow and we will go over it when we get to class tomorrow. Thanks so much for tuning in, and I will see you later.